like when you're dealing with those financial times, it's quite overwhelming, isn't it, at first? All these different ways of looking at it. So it needs a little bit of practice to get through this. But what I'm really trying to tell you here is that we want to keep it as simple as we can, you know, and the way to make it really stupidly simple, because often our mind, you know, has to deal with a lot of complexity while we're doing this anyway, which is simply using this. We start at 0 and we look at the percentage difference. And on top of that, what I usually do is when I do backtests, I don't look at cumulative products, I look at cumulative sums. Because what often happens is when you get backtests that look quite good in the backtest, when you do a cumulative product, they can really just go to infinity very quickly. And it's totally unrealistic and it doesn't make much sense. And we don't want that. What we actually want is something a bit simpler. And that's why I get away from this adding 1 and I just use the cumulative sum most of the time, which is effectively like what you call the log returns. So if you're interested in log returns, maybe look it up. It's effectively the difference between two log prices. So what it means is it's the logarithm of today's price minus the logarithm of yesterday's price is effectively like, you know, the compounding of this is like the percentage change in the cumulative sum. So that's what we get. Okay. So when we run this, it looks a bit different. So see, it looks actually a lot more linear. Log prices are actually, you see this more of a straight line. You know, when you think about compounding interest rates, right? It's a sort of exponential curve. And it's the same here. If we use, you know, if we say, oh, we just got 1% and another percent with interest rates, and we add the percentages, kind of a straight line, right? Every year we add a percent. And so if we compound it, then it's exponential. And so it's the same here. It looks a lot more linear than it would, you know, in the cumulative product case. But for all practical purposes, when you analyze backtests, often it looks a lot more realistic to use cumulative sum. Now, there's many different philosophies about this, but let's say you work in a fund, you're a fund manager, then oftentimes what happens is, you know, you produce or you provide a return for your clients, and they say they put in $1 million or whatever, and you say, okay, you know, at the end of the year, you get so much back, you know. So there isn't actually much compounding going on anyway, you know, because you have to pay your operating costs and all that. And so usually the truth is somewhere in the middle. You use a little bit of compounding and a little bit, you know, it's like halfway in between. And so, you know, sometimes, you know, you take a bit out, but you leave some in and so on. So usually the truth is somewhere in the middle. And, you know, it's a question of what you actually want to get out of the package. There is no right or wrong. That's important to understand here.
What I was thinking also is like that you could only, you know, let's say like 80-20 rule or something like this, you know, you take, I don't know, 20% out and 80% you put back in or something like that, right? So, yes, and that's depending on like your situation and what you're doing, I guess, right?
Yeah, the issue with all of that is it makes your simulations far more complicated. And
definitely
the simulation is not there to perfectly model what you're doing. Always remember, a simulation is just to establish whether what you're doing actually makes sense or not. You know, you don't want to, maybe if you have investors and you want to make really fancy, flashy, whatever charts, then you use one way or the other, whatever. But a simulation isn't for that. A simulation is, the question in the simulation is, does my trading strategy actually make sense? Is it useful? Is it any good? And that's what we're trying to establish. And we try to keep things as simple as we can from the outset, because the complexity will come in later. That's why I keep it extremely simple. Okay? There's a lot to learn.